All right. I want to welcome you all to the August edition of 2021 in the AWS. My name is Calvin Hendricks Parker. I'm your co-host for the afternoon. I'm one of the co-founders of this meetup, and we've been running here out of Indianapolis, but have an international appeal apparently, because I know David's coming in from Mexico City and Ben's in London. Follow us on Twitter and all the socials. You can mention us at IndieAWS or the hashtag IndieAWS. I want to thank our organizing sponsor for the afternoon, which is 6 Feet Up. Indie AWS is brought to you by 6 Feet Up, and 6 Feet Up is a software company that helps organizations build apps faster, innovate with AI, simplify big data, and leverage cloud technology. I co-founded 6 Feet Up in 1999 and have been CTO ever since. If you are interested in chatting with us between meetings, you can join us on the Indie Hackers Slack. That link right there should be an inviter to get you into the Indie Hackers Slack, and there's an Indie AWS channel in that Slack, so please feel free to join us over there. If you are still on meetup.com, make sure you claim your profile over on meetingplace.io, which is our official RSVP mechanisms for Indie AWS and Indie Pi. We switched over about 2 years or a year and a half ago, year ago-ish, and I'm much happier than I was when I was Meetup. So if you run a Meetup, check out meetingplace.io. I really love what they're doing there. And with that all being said, also jobs. If you are looking for a job or you are hiring, please make your way over to Indie Hacker Slack. They have a jobs channel on that Slack org as well. And that's a great place to put your job posting, because they'll also, if you're posting a position that's open, they'll put it into their newsletter, and they've got pretty good coverage, especially here in the Midwest and across Indy. All right. All that being said, I will turn this over to Ben Ellerby, who's going to talk about load testing with AWS serverless architectures. So I'll stop my share and let Ben take over.
Well, thanks for having me so much. My name's Ben. Today's talk's about load testing serverless architectures using serverless. Even the title shows I'm going to say the word serverless quite a lot. So just a fair warning on that. I'm actually VP of engineering at a cloud consultancy and agency called Theodo. We have offices in New York, London, and Paris. I'm over in London, but work with the New York teams quite a lot. And I really lead what we do in cloud native, and serverless. If you're interested in what we're doing in this space, we run the serverless transformation Medium, which you can find on medium.com. I also tweet a lot about what we do. You can follow me at Ellerby Ben. And a lot of our open source blog, podcast, newsletter, you can find on our website, theodo.co.uk/expert/serverless. I'll share the links afterwards, and there's a US version of that as well. But in any case, let's jump into the talk. So let's quickly define serverless. It's quite a broad term that means different things to different people. And then let's jump into load testing and how the two things combine. So serverless is really an architectural movement. It allows us to build and run applications and services without thinking about the underlying servers. Developers can send application code and it's run in a completely abstracted way, and they can simply just write code and it's triggered by different events or by HTTP requests. It's also the leveraging of third-party services to really abstract away backend logic and state. Things like Cognito for identity management in AWS or Okta outside of AWS, integrating those and the events around those into the larger serverless architecture is how we're typically building cloud native and serverless at the moment. There's also a framework called the Serverless Framework. It's a really great infrastructure as code tool. It makes talking about serverless quite confusing. We use it at one point in this talk, but we're really talking about serverless, the architecture movement, rather than serverless, the framework. Now, why do people take a serverless approach to building applications? Well, first of all, there's a cost reduction. Depending on the traffic profile, there can be a reduction in the overall AWS bill. But more importantly, there's a big reduction in ops. It's not no ops, but there's a big reduction in the security patching, maintaining, and updating of the machines that are running your code, because that's abstracted away from us. So the total cost of ownership of applications is massively reduced. Developers can also focus on delivering business value because they spend less time configuring Kubernetes clusters and building code around infrastructure. They more focus on the code they write being the unique business logic of that organization. And these applications are scalable from day one with quite big scalability, which we'll see later in the talk. And as we start to make more efficient usage of the resources in our data centers, hopefully we'll reduce the climate impact of that compute. And at the minute, the impact of cloud computing is almost as bad as the aviation industry and getting worse. So we really do need to find better ways to share resources in those data centers. Now, when people talk about serverless, they're not just talking about Lambda. Lambda is, of course, sort of the poster child for serverless. It's the serverless compute service that lets us write code in a number of different runtimes and have that be triggered either by direct invocation, by triggers from other AWS services emitting events, by HTTP through services like API Gateway, and is really how most people start to hear about serverless and see it used. The S3 is a completely serverless way to store things in the cloud. DynamoDB is a completely serverless NoSQL database. API Gateway lets us route events, HTTP, and WebSockets into our serverless architectures. Cognito is a completely serverless identity as a service tool, SQS for queuing, step functions for workflows, EventBridge for routing events through a distributed event-driven serverless architecture. The list goes on. There's really a big range now of services that enable us to build completely serverless architectures. And that gives us a great amount of power and flexibility. And when we do it well, we get a very pretty picture of microservices communicating completely asynchronously in an event-driven way. When we do it less well, there's a big tangle of different services, and sometimes you don't know what's happening. Hopefully, we're doing it well, and we're using good domain-driven design, and we're getting a nice outcoming architecture like this. But we still need to think about how we're going to scale this architecture when we're talking about very high load. So why do we need to think differently when it comes to serverless? Well, all the services are pay-per-use, which is great from a cost perspective. If you have certain traffic patterns, that could be a big reduction in cost, but it can also lead to things like denial of wallet attacks. Someone hitting your Lambda function hundreds of thousands of times before you realize that can actually build up a cost on your AWS accounts. Having the right alerting is one way to resolve that, but also having architectures that deal with it is the longer term solution. AWS service limits, both hard and soft, constrain how your application can scale. By default, there are different limit values and you have to get them raised. For instance, Lambda concurrency is limited. You need to ask for it to be raised. If you've not asked, then it won't obviously scale past that concurrency limits, which is good for protecting you from a massive AWS bill, from a mistake or from an attack. But when you're trying to scale a big application, it can also be quite frustrating to find out you were held back by a limit you could have raised in the first place. Some of these are hard limits. They can't be raised. You need to build your application to take these into account with queues, with making different technology choices in your architecture, and really making sure you know where the limits are and you know which ones can't be moved. Because serverless scales massively, you can also DDoS your third parties or other parts of your application infrastructure, which really does make people very annoyed. So I'd advise you to do everything you can to avoid that. There are things like the circuit breaker pattern. Jeremy Daly's written about a serverless circuit breaker pattern. It's a really great way to prevent this. But you do need to think, we've got this relational legacy database in the middle. We have 100,000 Lambda functions all hitting at the same time. What's going to happen? We have a third-party API that's actually quite expensive when we call it. What happens when we call it 1,000 times in the same second? And also, if they're not serverless, if they're not scaling in the same way with the same profile, are we going to knock them out, and are they going to let us keep using them? Now, cold starts also impact how we react to sudden spikes. Typically, when we have a large spike in demand, we're going to be triggering lots of Lambda functions that are in a cold state, meaning they're not warm and they don't have the application code installed and they're not ready to go. This is going to impact how quickly we can respond to spikes in traffic. As I mentioned before, there's a big combination of different serverless services that can build quite complex webs of different interactions, an event coming from API Gateway into a Lambda, into a step function, into EventBridge, into another Lambda. This can mean that different bottlenecks at different part of the pipeline of those events is going to cause different scalability profiles, which can be quite hard to take into account on paper. And this is where we need to test in the real environments. And finally, when we have multi-regional serverless architectures, that distribution of traffic can be really important. If we've distributed our architecture and we're scalable to millions of users, all of our users are in one region and hitting that region, it doesn't really matter how much we're going to scale in the other places. At the same time, if we have lots of traffic in one place and we're not deployed in that region, we're going to have a lot of latency, and that's also going to affect how our scalability looks. Now, I mentioned before briefly about cold start and warm starts. For those of you who haven't come across these terms before, when a function is invoked, AWS creates what's called an instance of that function that runs the handler code, the piece of application code you've written, and returns a response. Now, that function instance will remain active, waiting to process more events. And it's not particularly scientific, but at some point it will no longer be active. If it keeps getting triggered, it's going to stay warm and be as fast as it can be. But at some point it'll become cold again. The other point to mention is if a Lambda function is invoked again, while that first instance is processing it, another one will be initialized to process that event, and we'll have concurrency. Both will remain warm and both can then process more events. That cold start time, it's going to download the code, start the sort of pseudo container, and it's going to bootstrap the runtime, whether that's a custom runtime or one of the off-the-shelf ones, and then the code's going to start running. The length of that cold start time really varies, partly on your application code size, partly on the runtime that you're using. Java is particularly long. Node is quite fast, Python's quite fast. That's really going to affect how long that cold start time is. And part of it is that it's not an exact science, and that's going to change slightly depending on different factors outside of your control. But that's going to change how you respond to a big spike in traffic and what your latency looks like. The other point to mention is on the scalability of Lambda. So as I mentioned before, we'll have multiple instances responding to a particular event if we have the same Lambda function being invoked concurrently. Now, the number of concurrent instances that can serve that request is what's called the concurrency of the Lambda function. When we get a traffic spike, you can see there's that sort of exponential curve, and then we hit a burst limit. So we're gonna scale under that burst concurrency quota, which is a very fast way to scale up. And then after that, it's going to be 500 new instances per minute until we hit our overall concurrency limit, which is a soft limit that we can raise. But if we've not raised it, we're going to hit that limit and then be stuck from scaling. So if we're anticipating the big launch of a new social media site, we don't want that limit to hit our whole marketing campaign midway through. We want to test and make sure we've raised all relevant limits before we release to large amounts of users. And provisioned and reserved concurrency are also interesting topics to look into. We're not going to look at them today, but if you're dealing with the concurrency of Lambda, there are newer ways to help you sort of deal with some of these issues. Now, when we look at load testing, it's really about simulating different concurrent traffic levels on your application to validate its scalability. All those unknowns and uncertainties we just went through, yes, we can figure out a lot of them in the paper. We can write out all the services we're using, what their limits are, and have a think about what it's going to look like. But you're not really going to know until you see that complex interaction of different services triggering each other. And that's where load testing there's really no substitute for when we're trying to make strong claims about the scalability of our architecture. Now, typically, load testing falls into two categories. There's protocol-based testing, where we simulate traffic by just hitting the API level directly. And there's browser-based, where we're going to spin up a browser and simulate a real user's interaction with those browser elements, which are then going to go and trigger the realistic protocol-based requests hitting the APIs. Now, typically, serverless architectures are best tested at the protocol level. We're usually testing extremely high levels of scalability that would be quite cost prohibitive, quite complex, and quite slow to test in a browser-based approach. And that protocol doesn't have to be HTTP. It could be direct invocation through the AWS SDK. For instance, we have an event bridge, and potentially we've got a third party pushing events directly into that event bridge, and we have different services then processing those events and creating some results. We can actually write adapters for different load testing frameworks that can just send events directly into Event Bridge if we don't have that sort of forward-facing HTTP API. And of course, we could add an HTTP API if we wanted to, but it can be quite useful to really focus the scope of your load testing when you need to. But overall, we're typically doing protocol-based testing at the HTTP level. Now, the components of a good load test, and these are the same for serverless and not serverless, is that we have an exact replica of the production infrastructure, exactly the same services configured in exactly the same way. And if it wasn't cloud and serverless, it'd be exactly the same box. Here, we're going to use the same services with the same service limits applied, the same code. And as much as we can, we're going to simulate the same traffic. We need good observability tooling in place. There's no point running a test and not knowing what happened. Having that in place is sort of table stakes for starting the load test. We want the scenarios to be repeatable. We want to be as scientific as possible with this. We want to commit any experiments that we do to source control, both the scenarios that we were running and the results of the load test. So we can go back, rerun the load test and see if changes that we've made have actually improved the scalability. We need that ability to simulate very high load, and for serverless, particularly high load. And we want as realistic as possible those user flows to be. And finally, if we've got a multi-regional architecture, we need to think about the geographic distribution of our traffic, so it's not just hitting one region. Now, to make this a bit more concrete and talk a bit less theoretical, one of the applications we built actually at the start of COVID for a client is an application called Gamercraft, a US-based company, and they were building sort of tournaments on top of League of Legends. So to help create fairer tournaments, they would match players with similar skill sets and create tournaments with different prizes. Now, Gamercraft's platform needed to scale up to quite high levels of users. These tournaments are quite large, but also there's many periods of time where there's no tournament happening at all. So a really good use case for serverless, but we needed to be able to make sure we could peak for these different tournaments, and a lot of marketing goes into these tournaments, so we didn't want to do all the marketing, run a tournament, and then hit issues midway through. If we look at what the architecture looks like, an example service like the tournament service is composed of a number of Lambda functions, step functions, DynamoDB and S3. There's some shared resources like Cognito and API Gateway across some of the microservices, and then Amazon Event Bridge, which provides you with an event bus to send events between different services, will then allow us to route events between the other microservices of the architecture, the notification service, user service, match service, team service, and prize service. If we jump into an example of the flow in the tournament service, again, we're seeing many of the same suspects. We're seeing Lambda, event bridge, step functions, and this was actually quite a simple part of the architecture. And this is just one flow inside of it. It's quite a complicated different web of different functions and different services interacting that on paper would be quite hard to say. If we have 20,000 users, how many Lambda functions are going to be invoked concurrently? It becomes very difficult to reason about this and predict how close we're going to get to service limits. So what do we want to test? We want to validate that our cost estimates are as accurate as possible. There's typically a stakeholder in your team looking at the AWS bill, and there's typically people asking, how does this scale as we increase the number of users? And we can actually answer this question quite accurately these days. We also want to identify which AWS service limits we need to raise. And sometimes there's a lead time on raising those, so we need to get those support tickets in early. We also want to identify which AWS service limits can't be raised and design our architecture around those, or scale how we're going to launch the product around those. We need to verify if third parties are going to be effective and affected, and there's any non-service components that we need to protect from traffic spikes. We need to find any of those hidden bottlenecks that are in that sort of complex web of services. And if we're multi-regional, we need to sort of verify what the impact of that regional distribution of traffic would be. So how do we start? It sounds like a lot to do. Well, first of all, we need an environment to test against. And again, we need that environment to be exactly the same as the production environment. If we're pre-launch, we could run it against the production environments, but typically you want a completely isolated environment to run these tests against. Now, ephemeral is a pretentious word serverless people use a lot, which means short-lived. It means we have services like Lambda, which can run for a short amount of time. The architectures themselves can be quite short-lived. And if we have an 100% serverless architecture, we can just launch everything up in a very short amount of time, less than 5 minutes on the CI pipeline, run tests against them, and then shut them off. And it's pay-per-use, so it's not actually it's not that big a cost. At Theodo, we're typically using what we call serverless flow, and you can read about it on the serverless transformation website, but it's our sort of CI pipeline and way of working is we open a draft pull request on GitHub, it builds out a whole architecture specific for that user story, that ticket, that Jira ticket, Trello ticket, whatever it is. We then develop against that architecture, and then we go to merge in, we spin up another completely isolated test environment, we run tests against that isolated environment, and only then will we merge into a staging environment. Then we have that flexibility because the CI pipelines are very rapid with serverless, because they're very quick to spin up these infrastructures, and it's pay-per-use, so the cost isn't particularly increased. Now, the same approach can be used when it comes to load testing. We can spin up a completely isomorphic, completely same, an architecture with completely the same shape as our production architecture and run tests against them. Now, you do need to be careful you're running it in an AWS account with the same service limit ratios as the other, and matching those is something you need to check that we're doing. But typically, we can run completely isolated experiments on throwaway environments, which is something we could never really do before serverless. Secondly, metrics. We need to know what's happening before we try and shoot traffic at things. If we look at AWS Lambda through CloudWatch metrics, you're typically going to start looking at the response times, the error rates, and the throttles. Outside of that, with serverless, typically we get quite a distributed architecture, which actually makes understanding, observability quite complex. CloudWatch and X-Ray are really great tools inside of AWS. CloudWatch, of course, is capturing the logs, and X-Ray is doing distributed tracing. So we can see this event came in through API gateway, went through event bridge, went through a step function, hit a Lambda. Really useful for debugging, but also very useful when we're looking at debugging scalability issues in a load test. CloudWatch actually added something called Lambda Insights, which is quite interesting to look at these days, where you can see the function cost, duration, memory utilization. In Lambda, we can specify not only the timeout, as we were talking about before the talk started, but also the memory that we're going to give. We can see if we're getting close to that upper bound. And this is very useful for performance monitoring. We typically find, or I typically find, when I'm running load tests, it's good to have a dedicated third-party observability tool. One of them actually sent me a t-shirt, which I'm wearing today. Not intentional, but I've just realized the logo's on the screen. But there are others in the space. So there's Dashbird, Thundra, Lumigo, Epsilon, Datadog. There are loads more than that. Lumigo actually had some very interesting acquisition news recently, which is probably worth checking out. But these typically run on top of CloudWatch, or they aggregate logs in a particular way, and then they'll build out dedicated metrics and observability. If you're Calvin, you'll probably build out your own Grafana with your own very specific set of metrics that you're going to watch. But make sure you know the metrics and you have clear visibility on them before you start your load test. And not only can you see the number in real time, but you have the history of how that number changed, or those numbers changed. Secondly, we need a load testing framework. So Artillery, some of you will be familiar with. Gatlin is another one. There are a number in the space, but Artillery is a really great load testing and smoke testing solution that allows site reliability engineers, developers, and QA engineers to to run load tests and run different tests against architecture. If we look at a traditional artillery sort of test definition, we specify our target, which is the website or the API we're going to run load testing against, a number of phases, which are going to be the different sort of arrival rates and what we're going to ramp up to, the payload, which could be dynamically generated using something like Faker to generate fake company names, usernames, emails, etc., or a static file, a CSV of keywords. And then we have the scenario we're going to run. I've got someone's microphone going off. There we go. And then we've got the scenarios we're going to run against. So then we're going to see what paths we're going to hit, what we're going to put into the API calls. And to run that, we just run artillery run and then the name of the file, and that's going to run that test for us. But as I mentioned before, we've got this very large scalability requirement. We need to simulate a lot of traffic. Our laptop's not going to be up to doing that. And this is where we need to find somewhere to run our test from. Now, as you probably take from the talk and my job title and everything I've been saying for the last 10, 15 minutes, we're not going to run it on a server. We're going to run it in a different way. And that's where we really need a service that can run code without us having to think about or manage the underlying service and supports massive parallelism. And that's exactly Lambda. Lambda can do this for us. And in this way, we can test serverless using serverless. Now, luckily for us, there's a tool called Serverless Artillery, SLS Arts, which combines serverless with artillery to give you serverless artillery, which allows us to have instant, cheap, and easy to perform load testing. At least that's what the README says. But actually, it's very easy to run and very useful for doing this. What it will do is we'll run SLS Art instead of artillery. That's SLS Serverless Artillery. And we can run a script, and that will then deploy, run the invocations, and we can also kill and remove what it's deploying. And what it's deploying is a fleet of Lambda functions that are going to run that test. Some of them are orchestrated Lambda functions, some of them are sort of the worker Lambda functions. But for you, you're writing a configuration file that's then executed for you in a massively scalable, cheap, and pay-per-use way. One big caveat to this is that you should run this from a different AWS account. If you're testing the service limits of Lambda concurrency, and part of your load test is taking up your Lambda concurrency limits, it's going to get very confusing. Your logs are also going to get very confusing. Your metrics are going to be quite impacted. So I would say run this from another AWS account. And just one caveat to any load testing, always tell your third parties and your cloud providers that you're about to load test the application. Otherwise, they're going to think they're under attack. And the other part to running from a separate AWS account is we're going to have more realistic traffic paths. Also, we were thinking about geographic distribution. You can do clever things around which region you're running from and try and simulate different traffic paths, but largely just make sure it's a different AWS account that you're running the test infrastructure from. I mentioned before we should commit these experiments, so all tests should be repeatable experiments. We should have the context of why we were doing the test, the scenario template, and the results committed directly to the repository so we can analyze them in the future, but also repeat the experiment and also make changes and see if our statistics are improving. In conclusion, we need an environment to test against, metrics to make sure we know what's happening, and then that serverless testing tool. Serverless Artillery is a really great choice. There are other ways to do it. The key message here is that serverless can be used to load test your serverless architecture and make use of an existing load testing framework to abstract a lot of the complexity there for you. The components of a good load test we've gone over are having the exact replica of the production infrastructure, having observability tooling in place, making sure these scenarios are repeatable, having that ability to simulate a very high amount of traffic, having as realistic user flows as possible, geographic distribution of a multi-region, and committing all repeatable tests to some repository under your control. Now, I've gone through that quite quickly. Hopefully there are some questions. You can also find these slides at slides.com/Ben Ellerby. You can find other open source serverless content on our website, and service transformation, you'll find articles around serverless flow and some of the other things I mentioned. But maybe it's a good time to pause and see if there are any questions at this point.
I definitely have questions. Rewind all the way to the back. You started off with the denial of wallet comment. What kinds of techniques should folks be using to avoid that? Are there some like knobs and switches we can just turn on in AWS on our serverless to help with that?
It's a good question, and it can become a scary topic, right? One of the reasons
the talk next month will be Ben on denial of wallet.
Just tell me your AWS account and I'll do the rest. The service limits are there for a reason, the soft limits. They're not just there to to be annoying, they actually do protect you. So don't just raise some limits for the sake of it. One, AWS won't just agree to raise them to massive levels, but you also need to think about why you're raising it and doing it intentionally, because they are a really nice protection. I would set budgets, I would set alerts, and I know a lot of our alert channels become really noisy. When spend goes massively out of proportion, that needs to be in the high priority alert channel. How do people trigger these denial of wallet attacks? Some people are doing some advanced things around figuring out what your architecture is, but largely these are people who are just trying to denial of service you and didn't realize you'd scale a lot. And this is where typical anti-denial of service tools can be in place, have good caching. If you're in AWS, things like a WAF, a web application firewall, can be useful to an extent, definitely can stop some of the bots. You can look at dedicated cache providers that work on denial of service, but good alerting is key there. You can set up some automated rules to start shut things down and prevent access if it's going completely out of whack. AWS will also have some automated tools. You probably get a panicked call from an account manager at some points, but make sure those alerts are clean. Make sure you've got a clear understanding of what your spend should be so that you know what to do when it gets out of line. And web application firewall security best practices, it's the same concept of a distributed denial of service attack. So the same sort of countermeasures are key.
Awesome. Well, actually, does anyone else have a question before I keep going? Because I can probably ask questions all afternoon. Who else has got questions for Ben? It's your chance.
If you're like new to kind of learning about the cloud, where would you start? I would like to learn about it more from a security and ethical hacking perspective. So where would I like start?
That's a really good question. I'm sure probably some other people can jump in with an answer on that. I think Calvin would definitely say you should go to meetups, and I would agree. Really great way to meet people. Also good ways to find jobs in the future in that space. I would say, a lot of the cloud communities are very, online on social media, following people on Twitter, following people on LinkedIn, finding out what the good newsletters are in that space is a good way to sort of see what's modern in that space. Obviously, the cloud providers, many of the cloud providers have certification. AWS in particular has a strong certification path. That can be a good way to sort of build a curriculum for yourself. And it can be a useful way to show that you're qualified when you're looking for new jobs. It's definitely not the only way. And there's a lot of free stuff out there to help you in learning that, even if you don't want to take the exam itself.
Yeah. I was going to mention the, oh, sorry, Ben, I didn't mean to cut you off. Go ahead, keep going.
No, that's absolutely fine. I was just going to say Greg's dropped a link in for the self-paced labs.
Oh yeah, that's actually a really great link too. I was going to say on Twitter, Amazon has now a new Twitter account called AWS Developers, which is basically only developer related content on there. And they also have just released the AWS Heroes library. So there's curated resources by AWS Heroes, which are amazing folks to follow. I am humbled to be part of that group, but there are some amazing folks in there who produce just tons and tons of content. Dev2 has got just a whole AWS like sub channel inside there that's also great content for learning on AWS specifically, but there's lots of cloud agnostic topics in there as well.
So I have a question. It's a little off topic, but often when I hear this conversation about load testing, it's very focused on like web apps or APIs. And I'm doing stuff more like right now, data engineering and like ETL pipelines and stuff like that I would like to load test. And just curious if you have any resources or talks you could point me to for that. And I'm fine if you want to, if anybody's got some information after this, they could send out. But I realize it's a little off topic.
It's a good question. I don't have something immediately to point you to. I can tell you that, so we typically when we're building serverless architectures, we end up also building a serverless analytics pipeline using something like Kinesis to stream something into an S3 data lake, and then using stuff like Glue to do some processing. And then I hand over to a much smarter machine learning team, and I don't understand that bit. But that ETL process, we have used Lambda actually just to simulate writing data to the S3 bucket, just to see what was happening with the Glue pipelines. So we've written basically a script that will trigger a number of Lambdas actually using Artillery, and those Lambdas, their only job is to write fake data into the sort of input of the ETL pipeline, and then it's doing the rest. It wasn't particularly scientific. We needed to see if it was going to reach a certain threshold, and it did, and then we stopped. But I've not seen anything particularly in that space. I don't know if anyone else maybe has a better answer on that.
That's insightful anyway. But, yeah, and I'm learning the analytics part myself. I'm mostly a backend web developer, and it's kind of new to me. So I'm just hoping to, yeah, thanks.
It kind of leads to my next comment, which was I've never actually used Artillery, but I've used Locust as a load testing tool. And what I liked about Locust, and again, I don't know how to compare and contrast because I've never used Artillery yet, is that you can write that to do load testing on WebSockets or DNS queries or LDAP queries, or it's I don't know, I feel like it's pretty flexible. I don't know how that would you say that compares to Artillery can do lots of other protocols as well?
Definitely do some other protocols. I think they're called engines, and they can basically call different things. We wrote an engine once that actually just fired events into EventBridge because it was something we particularly needed to do. So it is possible to write engines. It wasn't a 10-minute job, but there are, for standard things, there's a set. I don't think it's as big as Locust though.
Yeah. So if anyone's never checked out Locust, I think that's a great load testing tool as well. Although I put it on my list to go check out Artillery because it sounds like it's a little more easy for straightforward tasks. Because it sounds like you just find it in YAML and away it goes kind of thing.
Exactly. And there's a few in this space, and most of them are open source projects. And then there's a company that will provide you a completely hosted version of them. So Artillery, actually, if you want to pay for the pro version, they'll run your tests for you in Fargates. They'll deploy inside of your application. A little bit less serverless than Lambda, but you need to put less thought into the CI pipelines. Someone else is doing that job for you.
Yeah.
I'm sure Locust and others are doing the same thing.
Yeah, we've run our Locust in Fargate as well. And it's nice because you just make a container, deploy the thing, and poof, it starts running. Who else got questions for Ben? What do you do when you've detected a really inefficient piece of serverless code?
It's a good question. I'd probably find out that I wrote it when I ran git blame and then get a bit annoyed. I mean, when it's Lambda, unless it's impacting users, I rarely am optimizing for like the millisecond billing. Lambda is typically not like the worst part of our bill, far from it, and it's probably going to cost more developer time to try and optimize. If it's impacting users, obviously, you can throw cache in front of things, you can make things asynchronous. One thing that people often, when they're moving into using Lambda, don't realize is that, of course, you can configure the memory, but as you increase the memory, you're also increasing the CPU that the underlying machine you're using has. So even if it's not a memory issue, if you ramp up the memory, you're then going to have a faster CPU, which is going to make my very inefficient code run a bit faster. And there's a tool called Lambda Power Tuning, which will actually, I think actually deploys a step function to do it, but it will try different configurations of your Lambda function, and you can choose if you're optimizing for performance or cost, and then it will balance out those two constraints and find the optimal memory timeout configuration for you, which is maybe a little bit over the top for most things. But if you do have something that's invoked a huge amount of times, it's a useful way to optimize it.
And what experience do you have load testing WebSocket type traffic? I think more modern applications are going to start using WebSockets. I've not done it with, I don't know how, or if you could do that with Lambdas, but it seems like for us, we use Fargate containers to run hosts that respond for WebSockets.
It's a good question. I know a team has done it, and I wasn't working with them at the time in the company, so maybe I can ping you something afterwards. But they were using AppSync, which is sort of the managed GraphQL interface from AWS, which also provides WebSocket connections.
Oh, I didn't know that.
Of course, it's protocol based, but it's slightly different, and it's. But actually, the interesting thing with them, they started using API Gateway WebSockets, moved to AppSync because they need to do broadcast. They needed to say for everyone in this group, send out a message. An API Gateway doesn't let you do batch sends, and you have to track who's doing what. So instead, they built a live chat application at the start of COVID for a video conferencing platform. And they basically just used GraphQL subscriptions, subscribed to a channel. Any mutations to that channel would then send out to the people in the room, which worked really nicely. I know it's scaled enough. They do have to raise some service limits, and that's backed by DynamoDB. But I can't remember how they did the load testing. I'll find out and get it over to you.
That'd be great. No, I'd love to know that. I mean, it's something we've done in our own applications, and I want to always do better. or at least collaborate.
Maybe we'll steal your idea in fairness.
Right. I'm happy to share what we tried. Any other questions for Ben? All right. Well, I think this is super exciting. I'm really excited we had you come as a guest here for Indie AWS. I love load testing. It's definitely a passion of mine as well. I think so many people don't think about it because usually they're on the long tail of applications. And I think when you start inching up that back toward the root of that tail, it can get really tricky. So let's give Ben a huge round of applause. Thank you so much for being with us. Really appreciate that. And then go enjoy another beer on me someplace. I'll pay you back at reInvent.
Sounds good. Thanks so much for having me. It's a really great meetup. I hope to join again.
Yeah, and we'll hang out for a bit here. I mean, we've still got another I blocked till 5 o'clock on my calendar, so
Nice.
I will start the music back up. And if people got more questions or conversations, we are happy to discuss and talk about all that. And again, thank you so much, Ben, for being with us. We will hang out for another 15 minutes or so. Ask
Great
any
talk.
questions. Yeah,
Got to
definitely.
leave.
No, thank you so much.
Bye.